Hello, welcome to this introduction to binary numbers. First of all, our regular number system is called decimal. Decimal comes from the word decas, which means group of 10 in ancient Greek. So any word that begins with deci usually refers to do with something to do with 10. So for example, a decade is 10 years, a decagon is a 10-sided polygon, decathlon is an Olympic event with 10 activities. Decimate in Roman times meant that if you were going to punish a group of people for something they'd done wrong, maybe failure in battle or some other reason, you'd take one out of every 10 person in that group and either kill or punish them in some way. That's where the word decimate comes from. And decimal, our number system, it's called decimal because we have 10 digits to make up any of our numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now once we get to 9, we don't have any more digits after that, and we have to make a new one, which is 1, 0, which is 10. We don't have it. We only have 10 actual symbols or digits we can use to make our numbers though. If I take 325, we all think we know what that means because it's a number system we were brought up with, so it's kind of instinctive in our heads. The way the numbers are set out, there's a hidden logic behind that I want to explain to you, which will help us understand binary numbers when we come to it. So each column represents a different thing. So the 3 represents the fact that we have 3 hundreds, the 2 means we have 2 tens, and the 5 means we have 5 ones. So we can show this in another way. We could say we have a 300 and a 20 and a 5. Okay, so it's 300 and 20 and 5. Alternatively, we could have said that we have 3 separate hundreds, 2 tens, and 5 ones. But all of these representations all come to the same point, that they all have the same value as 325. Now this is a decimal system. Decimal means groups of 10, and something I want to point out to you as well is that, so as you move from one column to the next, so from right to left, the value of the column increases by a factor of 10. It gets multiplied by 10, so 1 times 10 is 10. And likewise, as we move from the tens column to the next column, that also gets multiplied by 10. So 10 times 10 is 100. And if we were to carry on, we know that our next column would be thousands, because 100 times 10 is 1,000. This all seems very obvious, but it will make sense why I'm saying this in a minute. The word by means two, so as you can see here, a list of different words that start with the word by, or the prefix by, all denotes two things. So a biped is a two-footed creature, biannual means happening twice a year, a bicycle means 2 wheels, and so on. So we can understand that the word by means 2. So the binary number system only has 2 digits, 0 and 1. So any number we want to represent has to be represented using only 0 and 1 symbols, which sounds complicated, but it's actually easier than you think. So just to remind you, the decimal number system works like this. We have a column header here of 1, and then when we go to the next column, that number gets multiplied by 10. So because it's a decimal system, it's based on 10, so this becomes 10 here. And then the next column, we multiply by 10 to find that. It's obviously 100, and so on. Now, the binary system is based on 2, so we would have multiplied those numbers by 2. So let me show you the next step. The binary system starts, its first number again in the first column is 1, but we're not multiplying by 10 because it's binary, we're multiplying by 2. So as we go from this column to the next column,
this number here would in fact be a 2. And then as we go into the next column, again we multiply by 2. So here we would have 4. And then we multiply that by 2. And we would have 8. We multiply that by 2. And we would have 16.
Now you may start recognizing some of these numbers as numbers that come up quite frequently in our technological world. Computers are usually based, so the power of a computer are usually based on the numbers 1, 2, 4, 8, 16, 32, 64 and so on, because computers work on the idea of having of doubling their component size, basically. So how do we actually use this to write a binary number? Right, I just do one quick example here before I go back and re-explain. If I wanted to, say, represent the number 9, so to make the number 9, basically I can use a 1 and an 8, and that will give me 9. So you could say, in a very simple form, to make the number 9 in a binary, you need an 8 and a 1. Now we show that by saying, right, if we're not using it, it's 0, we don't need it. If we are using it, it's a 1. So to make the number 9, as we know it, in decimal numbers, so that's written in decimal number, if we want to write it in binary, we could write 0, 1, 0, 0, 1. Okay, now I'm going to explain that a bit more detail on the next bit. Okay, so for the standard decimal system, we're allowed to use any of the digits between 0 and 9, and we have the column headers 1, 10, 100, 1000, and so on. So we can easily understand that the numbers shown on screen is 5,724. We understand that's straightforward. But moving to binary, we don't yet have a clear understanding of how this is going to work. So decimals going up by multiplying by 10 each time. Binary number system, starting with 1, multiplies by 2 each time. So 2, 4, 8, 16, 32, 64, 128. Can carry on forever, but it's common when we're learning binary that we're going to do it in groups of 8 digits. Okay, now it's actually not as difficult as a lot of people think it is. So if I want to make the number, let's say 25 in binary numbers. So if you're trying to make 25, you look down the list and you think, to make 25, am I going to need, which of these numbers am I going to need to use? And you always start by considering the largest ones. So am I going to need 128? No. 64? No. 32? No. Now 16, yes, I can use 16. That's going to make up, yes, I can use 16. That's going to make up part of my number. So you need to do it. So I'm going to try and make the number 25, and I'm going to go down my options, my list of options, and think, am I going to use this option to make 25? So am I going to use 128 to make 25? No, you wouldn't. 64? No, you wouldn't. It's too big. 32? No, it's too big. 16? Yes, that will be used to make 25. So I'm going to make a record of what I've got so far down here. Am I going to use the 8? Well, if I use the 8, 16 and 8 equals 24 so far. So yes, using the 8 is a good option. I haven't reached 25 yet, but I'm on my way. Now, am I going to use a 4? No, I'm not going to use a 4, because if I use a 4, it's going to take me to 28, and that's too big. So I'm not going to use a 4. Am I going to use a 2? No, because if I use a 2, that's going to take me to 26, and that's too big. So I'm not going to use that. And am I going to use the 1? Yes, I am going to use the 1, because if I use the 1, I've got 16 add 8 add 1 equals 25, and that's exactly what we want. So the number 25 can be written in binary numbers as 0, 0, 0, 1, 1, 0, 0, 1. There you go. That's the basic process of writing a decimal number as a binary number. So let's do another example. If I want to make the number 43 this time, so I want to make 43. So I'm going to go down my list and think, do I need to use any of these numbers to make 43? So no, I don't need 128. No, I don't need 64. Yes, I'm going to use 32. So I'm going to write here 32. You can do all this mentally. You don't actually need to write this down, but it's just for illustrating the point so far. Right, if I use a 16, 32 add 16 is 48. That's already too big, so no, I'm not going to use the 16. Am I going to use an 8? Yes, I will use an 8, because 32 add 8 is only 40, so it's not gone over our target number yet. Am I going to use the 4? I'm at 40. If I add 4, it's going to take me to 44. So no, I'm not going to use that. It's too big. Am I going to use a 2? Yes, I am going to use a 2, because that will take me to 42. So I'm going to add 2. That will take me to 42. And that leaves me with using the 1. I have to use the 1 as well. Now, something you may have noticed is if I've ever got an odd number it's going to include the 1 at the end, because all the other numbers are even. So if you add even numbers, you're only going to end up with an even number. So if it's an odd number, you will always be using the 1 on the end. Okay, so 43 can be written in binary numbers as 0, 0, 1, 0, 1, 0, 1, 1. Let's do another example. Let's do 150. So, to make 150, am I going to use 128? Yes, I will use that. So, 128. Now, if I add 64 onto that, that's going to take me above 150. So I'm not going to use that. Am I going to use 32? Well, 128 add 32, that's going to take me to 160, so no, that's too big. So am I going to use the 16? Yes, I am, because 128 add 16 is 144. So we haven't gone over what we're aiming for, so we're on the right tracks. Am I going to use an 8? Am I at 144? If I add 8, I'm going to go over 150, so no. Am I going to use a 4? So 144, add 4, is 148. So yes, I'm going to use the 4. And that'll make it to 148. Am I going to use the 2? Yes, I am. Because that will take me to where I need to get to now. That will be 150. And no, I'm not going to use the 1. And hopefully that's obvious because it's not an odd number, so you won't need to be adding 1 onto the end. So 150 in binary numbers is 1, 0, 0, 1, 0, 1, 1, 0. One final example, just to make sure you've got it. You can pause the video, try and work it out yourself, and see if you get the same as me. So we're going to make 201. So are we going to use 128? Definitely we're going to use 128. Are we going to use 64? Well, 128 add 64 is going to be 180, 192. So yes, we will be using that because it's not taking us over our target. Will we be using 32? No. 16? No, too much. 8? Yes, we will be using 8 because that will take us exactly to 200. Sorry, I've done this slightly wrong. So far we're on 200. Will we be using the 4? No, it'll be too much. Will we be using the 2? No, too much. And will we be using the 1? Yes, we will be using the 1. So that's gotten us to 201. Therefore, 201 in binary numbers is 1, 1, 0, 0, 1, 0, 0, 1. Okay, I'll put some test questions up on the next screen for you to try yourself. Right, now we're going to do the reverse. I'm going to give you a binary number and we're going to try and turn it back into a regular decimal number. So let's start with something like this to start with. Now it's best to put it into the chart from right to left. So 1, 1, 0, 0, 1, 0, 0, 0. So what that means is that we're going to have a 16, 2 and a 1. Now a lot of you will be able to do that very quickly mentally in your head. But it's a 16, a 2, and 1 is 19. So if we put this onto our chart, we've got 1, 1, 1, 0, 1, 0, 1, 0. So that means that, sorry, I should delete this before. That means we have got a 64, we've got a 16, a 4, a 2, and a 1. So you need to add those together. Now hopefully you can see from number bonds that this is going to make a 10, so that's going to be 80. So 4, 2 and 1 make 7, so this number is going to be 87. So quite straightforward. On the next slide I'll give you a list of questions to try yourself.